It's Mr. Camp. Today we are talking chain rule. I would say out of anything I teach you the rest of the year, this is the most important thing. Okay, it's going to be similar to product rule and quotient rule, but even more prevalent. We're going to use it even more often. It's very, very applicable to lots of different situations. This is the thing you got to be good at. It's all we're doing the rest of the week. Most of next week as we review, it'll be on this as well. So make sure we got it, and we will go from here. All right, so chain rule today. Broken up into 2 lessons. Let's get this first part. So chain rule is known as the outside-inside rule. We use this thing when you have a composite function. Okay, we did a whole lesson on composite functions back in pre-calc. But remember what a composite function is. It's like f of g of x. There is a function inside of another function. Okay, this thing right here is a composite function. We've got the inside, 5x squared plus 2x, and we've got the outside that the whole thing is cubed. It's a composite function. If I want to take the derivative of a composite function, we are going to use chain rule. Here's how it looks. You're going to take the derivative of the outside function. You are going to rewrite the inside function, and then you are going to multiply times the derivative of the inside. So here's what that means. We're going to take the derivative of the outside function. So that's this part. Oh, okay, it was cubed. So we put the 3 in front. We subtracted 1 from our exponent. It was 2. We are going to rewrite the inside function so that 5x squared plus 2x is going to stay the same. And then we're going to multiply by the derivative of the inside. The derivative of the inside, 5x squared plus 2x, gets me 10x plus 2. Notice that that's in parentheses because it would definitely matter here. Boom, that is my derivative. Derivative of the outside, rewrite the inside, times the derivative of the inside. Okay, I'm going to say lots of goofy things here in this lesson because they're things that help me remember, but just kind of hang on for me. All right, so let's look at example number 1. We can tell it's a composite function. The thing that's pointing that out probably the most is the fact that there are parentheses. There's important stuff inside the parentheses here. So we've got the outside function, which is the square. We got the inside function, which is 2x cubed minus 4x. Take the derivative of the outside. So 2, subtract 1 from our exponent, boom. We're going to rewrite the inside. So 2x cubed minus 4x. And then we're going to multiply by the derivative of the inside. The derivative of 2x cubed is 6x squared minus 4. We got to throw it in parentheses. That is my derivative using chain rule. Okay, when I think of these problems, I like to think of them as a mama and a baby. Okay, if I look at that function, I got the mama function. The mama function is the square. Okay, that's the stuff in yellow. Boom, that's the mama function. And then you got the baby function inside her belly right there. Okay, the stuff inside the parentheses. So here's how we do that. We take the derivative of the mama, we rewrite the baby, and then you take the derivative of the baby. You put it on the outside, take the derivative of it. Is that weird? Absolutely, but it helps me to remember what's going on. Take the derivative of the mama, rewrite the baby, and then times the derivative of the baby. Let's do it again. So looking at number 2, it might not look like chain rule right from the start, but it is. I hate square roots, so I'm going to rewrite that as 1/2 power, and it's x to the 4th plus 1. So I didn't do any calculus, I just rewrote it. We are taking the derivative. We are going to use chain rule because there's an outside function and there's an inside function. Take the derivative of the outside. The derivative of 1/2 is 1/2. Subtract 1 from my exponent. I'm going to rewrite the baby. So if I rewrite the baby here, I'm going to have x to the 4th plus 1. And then I'm going to multiply by the derivative of the baby. The derivative of x to the 4th is 4x cubed. Ta-da. That's it. Okay, and this is a free response question, meaning it's not multiple choice. So we're good, but if we reduced this, you have to be able to recognize, is what I got right here, is this answer right here, is it the same as this? Are those two things the same? Hopefully you say yes, because I've got the 1/2 and the 4, that's where I got the 2 from, x cubed. And then that thing, since it's negative, could go on bottom, and the 1/2 gets me the square root. You got to be able to recognize that those two things are the same. Let's do another one. Example 3, sine of 3x plus 1. Okay, cool. There's a mama, there's a baby. Take the derivative of the mama. The derivative of sine is cosine. Okay, if you've forgotten that from last week already, you got to remember that. We rewrite the inside. And then we're going to multiply by the derivative of the inside. The derivative of the inside here is going to be 3. So my final answer is 3 cosine 3x plus 1. You don't have to rewrite it. But it's the same thing. Derivative of the outside, rewrite the inside, derivative of the inside. Try the next one. Derivative of cosine. What's the derivative of cosine? I got a mama. I got a baby. Derivative of cosine. Oh, that's negative sine. We rewrite the inside. So I'm going to rewrite 2x cubed. And I'm going to multiply by the derivative of 2x cubed. That's going to get me 6x squared. 6x squared. We could simplify that. That's perfectly fine, though. I'm good. Let's look at example 5. I don't love example 5. Probably a little bit harder than it needs to be, but we can handle it. What rule are we going to have to use here on example 5 to take that derivative? Did you say chain rule? Well, you are correct. You're going to need chain rule because I got an outside and I got an inside. Did you say chain rule? Well, then you'd be right because I've got an outside and I've got an inside. Did you say quotient rule? Then you would be right because I've got a function on top and I got a function on bottom. Okay, I've got two x's and they're being divided, so I need quotient rule. So, with that being said, this one's going to be ugly. We're doing quotient rule. Remind yourself of quotient rule. That is low d high minus high d low all over low low. Let's do it. Low. Write it down. So that's this guy. D high, the derivative of the top. So I'm going to need chain rule here. Derivative of sine is cosine. Rewrite the baby times the derivative of the baby. The derivative of 2x is just 2. Minus high. D low, the derivative of the bottom. The derivative of the bottom is going to be 2. Rewrite the baby, 4x minus 3, times the derivative of the baby, which would be 4. All over low low. Low low would be 4x minus 3 all to the 4th power because it's squared. That's my answer. Is that ugly? Yeah, it's ugly. But it's what I needed. I needed quotient rule and I needed chain rule 2 separate times. Okay, keep with me. We're going to keep going here. Just keep rolling along. Example 6. 3x squared, tangent of 2x. What rule am I going to need here? Did you say chain rule? Yep, you need chain rule. Did you say product rule? Yep, you need product rule because I've got this thing right here times another thing with x in it. So I'm going to need first derivative of the second plus second derivative of the first as along with chain rule. So let's do it. First times the derivative of the second. The derivative of tangent is secant squared. That's the derivative. So I'm doing chain rule here because I'm doing the derivative of this thing. So I took the derivative of the outside. I rewrote the inside times the derivative of the inside plus second times the derivative of the first. The derivative of 3x squared is 6x. Done. Let's try one more here. I'm going to change number 7 just a little bit, just to make it a little bit tougher since I'm not with you. Instead of tangent, let's make it secant. Secant squared of x. So I don't really like that either. I would write that as secant of x to the 1/2 power. I don't need product rule. I don't need quotient rule. All I need is chain rule. I've got an outside. I've got an inside. So let's do it. I got to take the derivative of secant. That's the mama function. Take the derivative of the mama. Well, the derivative of secant would be secant tangent. Then I'm going to rewrite the baby. And this one's weird. Don't let it be too weird to you. But I rewrite the baby. There's 2 spots for a baby, so I'm going to write the same baby in both of them. And then you just got to see it once. But when I take the derivative of the inside, it's just one time here. 1/2 x to the negative 1/2 power. That is the answer. We took the derivative of the mama, the secant, that gave me secant tangent. We rewrote the baby in both spots, but then all we had to do was multiply by the derivative of the baby just one time. Kind of a weird problem, but you can handle it. Okay, let's go to example 9. Cosine squared of 3x. So cosine squared of 3x. We look at this thing. First thing you should recognize here is saying that 2 is in a weird spot. Remember, that's the same thing as cosine of 3x all squared. That's the same thing. Don't let that be weird to you. We are taking the derivative of that. So if I'm taking the derivative of that, what am I? Do you see something inside of parentheses? I got this inside of parentheses, but I also have this inside of parentheses. That problem not only has one chain in it, but in fact it has 2 chains. Oh yes, everyone's favorite early to mid 2000s rapper. 2 chains. That is 2 chains. Yes, sir. That is a 2 chains problem. We have 2 different chains going on. I've got an outside, I've got an inside, and then I've got another inside problem. This is a 2 chains. And of course, you got to spell that thing with a Z in respect for who he is. All right, so here we go. Might be dumb, but it helps me figure this out. So I like to think of this as like a Russian nesting doll. Okay, if you know what a Russian nesting doll is, you know they kind of look like this. They're like these little wooden dolls like that, and they got a little break in them. And when you open that thing up on the inside, you're going to have the same looking doll, but it's just a little smaller. And if you open that up, you would have the same. I don't know why my doll looks so ugly, but it keeps going down smaller and smaller and smaller. That's kind of what's going on here. Okay, so we just do it. Don't overthink it. We take the derivative of the mom. Let's color code it to help you out. So I'm gonna go 2, boom. Instead of 2, now it's the first power. We took the derivative of the mama. We're gonna rewrite the inside. So the derivative of the inside is gonna be cosine of 3x. Cool. Now I'm going to take the derivative of the inside. So now don't worry about anything else but just that cosine of 3x. Well, if I'm going to take the derivative of cosine of 3x, that's going to be a chain rule problem. What's the derivative of cosine? The derivative of cosine is negative sine. I'm going to rewrite the inside again. That 3x stays the same. But I'm not done yet because I haven't taken the derivative of 3x. Now I got to take the derivative of this baby. The derivative of 3x is going to be just 3. That is the answer to this question, or negative 6 cosine 3x sine 3x. If you were to simplify that, don't over worry about the fact that a baby has another baby inside. It gets kind of weird. Don't stress. All right, we're just doing double chain rule there. We took the derivative of the mama, we rewrote the baby. Took the derivative of the baby, rewrote the second baby, and then took the derivative of it to get times 3. It gets really funky, but don't let it be too bad. Let's try one more. Sine to the 5th power. All right, well, that is sine of x squared minus 1, and that is all to the 5th power. So this is a 2 chains. We're going to take the derivative of the outside. We're going to rewrite the inside. Let's color code, sorry. You don't get to see me do these problems every day. We don't get Bellworks and everything else, so I might as well make these good. Sine. We're going to rewrite the inside of that thing, so that's that x squared minus 1. So we took the derivative of the outside. That's the 5 and the 4. We rewrote the inside. All right, cool. Now we got to take the derivative of this. The derivative of sine is cosine. But I got to rewrite this baby, x squared minus 1. Then I got to take the derivative of that baby. The derivative of that baby is 2x. Boom, there's my answer. I could simplify it a little bit, but that's going to get me to where I want to be. Number 11 is just application. I'm not really too worried about it. In this crazy time, I would rather us understand the big stuff and not worry about too much about some dinky things. Okay, hope that makes sense to you. If you got questions, let me know. Come to our Zoom meetings on Monday, Wednesday, Friday. I'd love to talk to you then. Have a good one.